Welcome everyone, you're watching Simulacra and I'm Bryson and this is session 9 of how I'm building a decentralized application. Now, in last session we kind of did a lot. It was a very testing heavy session. We made sure that the entire flow and backend for using the application to post a crypto address and retrieve the balance worked, and it did. We were able to retrieve the balance of a demo wallet that I have in MetaMask. And so for this session, I am building out the entire community pool aspect of the application where users will be able to deploy a community pool, fund that community pool, and then the owners can use their keys to withdraw the funds from that pool. So I'm going to build out the entire backend and I'm going to deploy the community pool to a testnet to see if we can actually deploy it to a mainnet. We're going to use some Sepolia Ether. In last session, I showed all of you how to get Sepolia from a faucet. So this is going to be a really cool session. So after this session is going to be the major endpoint for the series. And after this, it'll be a lot of front end and aesthetic work that I'll be doing. If you have any questions regarding anything that we went over in this session, remember to comment down below, like, subscribe, share with your friends, and let's get into it. But first, I need to make sure that users can use MetaMask or another injected wallet provider on my application so that they can sign transactions and actually deploy community pools, because it's going to cost some amount of tokens to deploy a community pool in terms of gas fees, network fees, lightning fees, and things like that. So I went to ChatGPT and I asked it to develop a prompt so that I could give it to an agent in Cursor to perform the task of making sure that this application is MetaMask Wallet compatible. So I'm going to copy my prompt from ChatGPT and paste it into the agent. Up here, I'm going to press plan so the agent is in plan mode and doesn't fly off and start building. All right, so the agent gave us a plan. I think the plan looks pretty good and goes through everything that I want the agent to do. So I'm going to come to the chat and say at docs, I am adding a new doc. So I'm going to type in the documentation from ether.js, press enter, and then I'm going to confirm this is ether.js so that the agent has access to ether.js. And ether.js is a library that aims to be a complete and compact library for interacting with Ethereum blockchain and its ecosystem. So it's used to create wallets like MetaMask and create decentralized applications and other tools and simple scripts that require reading and writing to the blockchain. So now that we know that our agent has access to ether.js, we can tell it to implement the plan and we'll build it out. So the agent is done. We were able to build out the backend for connecting your MetaMask wallet to our application. So if we go to the dashboard for our application, we can see it says connect wallet. And if we press connect wallet, oh, look at that. The MetaMask wallet browser extension will pop up, and then you can just enter your password and sign into your MetaMask wallet. So we'll see if this works now. So over on our app, it displays the MetaMask wallet as connected. And then if we go to the MetaMask browser extension here and we type on our account, it says this account is active because it's connected to our application. And then if we click on it and we go to here and manage our permissions, we can actually disconnect from our localhost on our application. So our localhost up here in our URL is the same as our localhost here, so we know that our wallet is connected to our application. So let's disconnect that for right now. So back in Cursor, now that we know that our application can actually connect using an injected provider, and that injected provider being the MetaMask wallet through the browser extension. Let's open up a new agent and let's give the agent a new prompt for actually building out the deploy, fund, and withdraw community pool capabilities. And so I have a prompt that I already created that we're going to post into the chat here. And so this prompt is pretty simple. It's just saying to create smart contracts for deploying, funding, and withdrawing community pools. You have access to the file Foundry Practice, which contains the code files listed below. And Foundry Practice 2 is a project I was using to learn how to use Foundry to test and deploy smart contracts. And so I already have the code written up, so I'm just going to give the agent all of those files. And then I'm also telling the agent to make sure that each smart contract for deploying a community pool uses that same flow of the application to create the community pool contract. So we want to make sure that the contract that is posted to the network or the blockchain has the pool description, the community pool name, the fund amount, any additional owners, and the pool expiration date. And then we want to tell the agent the available tokens that can be funded and to use Anvil through Foundry and our Alchemy keys to deploy the smart contract on a testnet and then actually to test to see if that smart contract has been deployed. So let's let the agent build and see what the output is. Now I am going to build out the backend for deploying, funding, and withdrawing from community pools. Okay, so right now the agent is running through testing the community pool process. And so I gave the agent the prompt to use Anvil to spin up a node environment with keys and funds to test deploying a community pool. So I just named the community pool test pool, gave it a pool description, a contribution amount, and an expiration date, and then told the agent to test and deploy this to a Sepolia testnet. So right now it's going through, actually working through deploying our community pool to a testnet, and it's looking like it's going well so far. Right here, as you can see, we have the broadcast deploy community pool. So we know that our community pool is actually being created. The agent is telling us that it's setting up one EVM. This is the estimated gas price to Gwei, and then the estimated total gas used for the entire script. And this is the estimated amount required in Ethereum. And so when our users are using this app, they will press deploy a community pool, and all of these fees will be taken out of their MetaMask wallet when they execute this deployment. So after this agent is done testing to see if it can deploy a community pool to a testnet, a Sepolia testnet, I'm going to manually, inside of the app, do the same thing where I deploy a community pool to the Sepolia testnet. And then we'll go to Sepolia Etherscan and see if our transaction actually ended up on the blockchain. And that is how we know that we have been successful. All right, so our agent is finished, and it said that it was able to deploy this smart contract using an Anvil mock or an Anvil testnet node. And this is the address for the community pool contract. So if you put this address in Sepolia Etherscan, nothing will actually come up because Anvil is just a development node infrastructure. And so Anvil would generate you keys and funds for different crypto addresses, but none of these funds and keys are real. And so we want the agent to deploy now to an actual Sepolia testnet so that we can see this transaction on the blockchain. So the agent is actually telling me that it cannot deploy this community pool to Sepolia from this environment because there's no Sepolia RPC URL in our .env.local environment. And then it also doesn't have a developer private key available for the tool to run. So it would need a real funded account and or its interactive wallet. So I have that in that I have MetaMask in another browser and I have my application in another browser.
So I'm going to ask the agent if I am just ready to manually deploy the community pool to Sepolia testnet using my MetaMask wallet. All right, so our agent says we are good to go to manually deploy this community pool. So I'm going to come over to my application and let's see. Let's click deploy a community pool, and we want to make sure we have the correct MetaMask account. We have both of our accounts connected to our account. That's what the green active bubble means. So we are in the account 1. And as you can see in the background, when I switch accounts, this address will switch in the application also. All right, so we're in the correct account. Now we're going to go to deploy community pool. We're going to name it test pool and say test pool. We are going to fund it with, let's say we fund it with $1. We don't want additional owners for now, so we're going to make it expire in say 2050, and then we're going to review. So pool name, pool description, the supported assets, how much we're funding and the token that we're funding with, and then pool owners, expiration date. So let's deploy this. All right, so perfect. So it did exactly what we wanted it to do. It opened up our MetaMask wallet, and it shows us all of the fees that will actually come about from deploying this smart contract. And then all of this hex data is all of the information regarding our smart contract. And obviously, we can't read this as a human, but this is information that blockchain nodes can read to discover and learn about your contract, what are the rules of your contract, who owns your contract, what type of contract it is, and so on. So we'll press confirm, and the app says we are working. So now that the app processed our transaction, we are now getting another transaction request to confirm that we are interacting with this account from our localhost. And this warning is just that this is a localhost and I don't have it on an actual browser. And the amount of Ethereum that we are sending. So let's confirm this. And now our application gives us a review of our pool. So it gives us the contract address, the deploy transaction address, and the fund transaction address. So we should be able to take this contract address and go to Sepolia Etherscan and see this contract on the blockchain. And if we come to Etherscan and paste the contract address, we can see that there's one contract from 42 seconds ago. It is a fund type of contract where you can fund it. We have the transaction hash, and we have the amount that is now in our contract. And then we can see all of the transaction fees and gas fees and things like that about our contract. And so this is super cool. So now we know that our application can actually deploy a smart contract to a blockchain, and that smart contract can be funded with a token of the user's choice. So I think this is a great place to stop for session 9 of how I'm building a decentralized application. If you have any questions regarding anything that we went over in session 9, remember to leave your comment in the comment section below. Like, subscribe, support the channel, send to your friends and family, and you're watching another video from Simulacra. I'm Bryson, and I'm out. Bye, everyone.